let's talk a bit more about what do you want to actually think about? What do you want to do when you generate your SBOM? And then maybe some of the things that you want to avoid. And this starts to get into some of the things that I've already discussed. Starting first and foremost, that if you want to, generate your SBOM, make sure that you do it one per service build, and then per application build. And so having those individual services SBOMs is important, so that way you know where to go back to anytime you need to do the remediation. But you do want to make sure that you have that final application build in order to have your true representation of the application's install plan. And so the kind of don't side of that is you cannot assume that the individual install plan for a service will be the same as that final application install plan, even though knowing both is very important. So do keep that in the back of your mind as you think about where you choose to integrate for your SBOM management or your SBOM generation activities. As you think about formatting, definitely both CycloneDX and SPDX are very, very popular formats. I think that a CycloneDX XBOM with an embedded VEX is probably best for security. Now, with that said, SPDX does now, as a 3.0, support embedded VEX as well, which I think is very, very exciting. I mean, I think that does kind of level the playing field there. And so I think both CycloneDX and SPDX are, great formats. And in particular, when they're annotated with your VEX information. Now, the thing about VEX, right, your vulnerability exchange, is it's only as powerful as the accuracy of the information, very similar to analysis, as included. And so that means including things like a status justification, right, or status and justification, whether that is affected or not affected. And if it's not affected, why? What is your kind of definition there? Some type of response, right? Well, is this something that's going to be fixed or will it not be fixed? And then what details do you have to kind of back up the proof of why you're making a particular assertion? And so if that information is not included as a part of the VEX, I would consider that to be an incomplete VEX, and one that is maybe potentially helpful but not as valuable, and it will not allow for you to reap as many benefits as you can when using kind of SBOMs for security. Going down to my next bullet point there, I did want to kind of call out some fields that I think are super important as you think about wanting to ingest SBOMs in particular. And that is like kind of Perl and CPE. I definitely, do continue to gravitate and resonate with the Perl spec more than the CPE spec, given the standardization there. But I do think CPE has its place and has its value. And so just making sure that you have some form of unique identification that can be externally verifiable, right, by some form of third party, is what is going to then allow for you to truly take advantage of an SBOM generation program. Having some of these additional fields like the supplier and the author and the name and version, all the things that kind of go into the minimum elements and some of these additional requirements coming from all these government regulations, I think is very, very helpful for sure. But that unique identifier is definitely going to be the most important. And the reason being is, and this kind of goes immediately into kind of my don't advice for you, which is it is risky to assume that any information that is provided is accurate, meaning that if I say that I'm using React version 1.4 and my Perl or my unique identifier is actually saying that for this particular package it's coming from React version 1.6, that unique identifier is what I would actually use as true if I would go grab that package to then start analyzing that information, because those are going to have distinctly different vulnerabilities for them. As we are all human, we make mistakes. We can provide a supplier field, but you can put anything you want in that field, right, depending on where your SBOMs are coming from. Once again, this is more so talking about manually generated SBOMs or ones coming from open source tooling, as compared to like your enterprise tooling like FOSSA, where we only use unique identifiers in order for us to provide that information, and thus we can declare its accuracy. And so that's just something to kind of keep in mind. And then lastly, after you're generating these SBOMs, where do you put them? And I think that continues to always be like a really interesting question, because after you've generated, it's very easy for us to just go end up in somebody's Google Drive folder somewhere, or OneDrive, or whatever your cloud storage is of choice. And I would highly recommend that you think about storing them in a centralized SBOM repository. Commonly, some people include them in the root directory of their particular repos. I think having a centralized repository is even better, because then you can better represent the full application organization rather than just the individual microservices. And this also gives you, all the benefits of version control, which means you get to go back and do additional revisions to be able to have that historical tracking, which I think is actually very, very powerful. And so having that stored somewhere, and I think, of course, the best option is things that we'll get into from an import perspective, which is then having your enterprise SEA tooling, if they support SBOM import, which we do, be your centralized ingestion. And that's actually an area that we'll continue to make heavy investments in over the course of this next year, because I do view that as probably one of the largest opportunities in the SBOM space from a pain alleviation perspective, right? Give me a centralized repo where I can dump all my SBOMs in and then begin the search and query across an entire organization. And that's the vision that FOSSA both supports today and will continue to beef and improve up over the course of the next year. So a couple of, kind of key takeaways or, points to note on Vex. I think while Vex is a great, prioritization input, you do have to kind of compare your own risk tolerance against the risk tolerance of the organization making a Vex statement. And I'll dig into that a little bit more here on my next slide. But I think that there's kind of two potential pitfalls with Vex, in particular in embedded Vex, which is one, vulnerabilities today and fixes for that matter do not equal, CVEs and vulnerabilities tomorrow. I mean, the new ones are constantly coming out. And so unless you are operating in a standalone Vex model where that's constantly being updated, in practice, a Vex statement is immediately inaccurate the moment that it's generated because you don't have any context at that point what new vulnerabilities have been introduced. Now, with that said, I don't want to be doom and gloom on Vex. I think it's an absolutely fantastic standard. I think it's given us extremely far to starting to deal with a lot of the noise of that, but I do think it is just something to be cautious and mindful of as you think about handling it. And then, on that flip side, if a particular software vendor views a particular vulnerability because the component is not included in production code as fine, right? Maybe the vulnerable function in particular is not included in production code. And from their perspective, that's an acceptable risk. For your perspective, because you may be in a more highly regulated industry, maybe that's not acceptable risk from you. And so even though a status may be not affected, really digging into the justification and details on why a particular vulnerability is not affected, I think does become very important as you think about, what information that you would like to glean from a Vex statement.